And I know that trig is one of the things that grade 11s really struggle with, because when we compare grade 11 trig to grade 10 trig, it really does start to get a lot more difficult. Anyway, so Peter's told me that he has been through the cast diagram with you, and the cast diagram is super important for us to be able to understand and work with our reduction formulae. So what I want to do is go through the cast diagram again with you, and just make sure that everybody understands how it works, and then we can start talking about reduction formulae and the answers that we get when we are reducing, and in fact what reduction is and what it means, etc, etc. So I really love it when you interact with me. If you've got questions, please post them in the chat, or if you want to unmute and ask, then please do so. That's why Coco and I are here. We're here to help you. All right, Lee, I see you've got a hand up. Do you want to ask a question quickly?
No,
Lee, you raised a hand?
No, I don't have a question.
You don't have a question. Okay, we've got the same name. Okay, cool. All right, so let's get started. So the cast diagram is there to help us remember in which quadrants certain ratios are positive. Okay, but before we get into all of that, what we need to understand first and foremost is that in trigonometry, we humans, we have decided that here is 0 degrees. Up over here is 90 degrees. Over here to the left-hand side of that is 180 degrees. Down here at the bottom, that we've decided is 270. And then when we get back here again, we've done a full circle, which is 360 degrees. Essentially, your terminal arm, your hypotenuse, okay, your terminal arm is anchored at the origin, like the hand of a clock. And it can swing about the origin in an anti-clockwise or a clockwise direction. So when we go in an anti-clockwise direction, grade 11s, angles are getting bigger because it starts at 0 and then increases to 90 and then increases to 180 and then to 270 and 360 and then gets continually bigger. Right? If we go in the other direction, so in other words, sorry, what I should say is so that when we are going in an anti-clockwise direction, our angles are positive. If we change direction and now we go in a clockwise direction, that's where we get negative angles. So just like I can raise my terminal arm up and it comes to rest here in quadrant 1, and I can say that I have gone plus 30 degrees in this direction. If I change my direction and I go 30 degrees in the opposite direction, I call that minus 30. So plus and minus are direction. Plus for anti-clockwise and minus for clockwise. All right, that's the first thing. The second thing that we need to bear in mind is that it depends which quadrant we are in. The signs of X and Y change. So when we are working in the first quadrant, and this is the first quadrant over here, it's always the first quadrant, our X coordinates are always positive and our Y coordinates are always positive. This over here is quadrant number 2, and here our X coordinate is negative and our Y coordinate is always positive. Okay, so to the right of the y-axis, X is positive. To the left of the y-axis, X is negative. Y is positive above the x-axis and negative below. So now when we come down into quadrant number 3, this is always called quadrant 3. Here we find that X is negative and Y is negative. And then this quadrant over here is called quadrant number 4. It's always quadrant number 4. And here X is positive and Y is going to be negative. So that's why our trig ratios change sign. This is because, okay, sine theta is y over r. And cos theta is x over r. And tan theta is y over x. Okay, so we can see that when we're in quadrant 1 or quadrant 2, y is positive. And that's why over here, okay, we call that, sorry, we call this one as the C, I beg your pardon. This one is the A. We would say that in quadrant number 1, we use the A in quadrant number 1 because all ratios are positive. That's because X is positive, Y is positive, and R, which is the length of the terminal arm or the hypotenuse of the triangle, R is always positive because it is a distance. So that's why we use the letter A for quadrant number 1, because X is positive, Y is positive, and R is always positive irrespective of which quadrant we are in. Then when it gets to quadrant number 2, this is where we put an S, okay? And that's because only sine theta is positive in quadrant number 2. That's because Y is positive. Okay, so we've got a positive Y over a positive R, which gives us positive ratio in quadrant number 2 for sine theta. X is negative, so that means that cos theta and tan theta would be negative in quadrant number 2. The letter T goes into quadrant number 3, and the letter T is for the tan function. It's only the tan function that is positive in quadrant number 3, and that's because tan theta would be negative y over negative x, and we know that when we divide a negative by another negative, we end up with a positive. The letter C is used for the 4th quadrant because it's only cos theta that is positive in quadrant 4, where x is positive and y is negative. Okay, remember cos theta is x over r, so any trig ratio containing y would be negative. So that's why sine theta and tan theta are negative in quadrant number 4. So very important, we always have to bear the cast diagram. So CAST in mind when we are doing reduction. Okay, so our reduction formulae come from the task cost diagram, and I'm going to talk a little bit about what reduction formulae are and where they come from, and how we get them. Okay, so the first of all, before we do that, when I talk about reducing or reduction, what does the word reduction or reduce mean? What am I doing if I reduce something? In English, what does it mean? Can someone tell me? Sure, Sisipo?
When you reduce something, you make it smaller.
100% Sisipo. Okay, and I see a few of you have popped that into the chats as well. Cool. Yes, Younger. Yes, Elspeth. Okay, decreasing is another lovely word. Well done. Okay, so Younger as well. Intercorso, yes, making it less. Okay, DNL, making it smaller. Bonga, yes, to make something smaller. That's perfect. So what we are doing when we are working with reduction formulae is that we are trying to write all angles as though they are acute. Okay, so that's the idea behind reduction, is we're trying to write all angles. We're writing all angles as if they were acute angles. Okay, so acute angles means that they are smaller than 90. So the word acute has a very specific meaning. It means that the angles have to be smaller. All our angles are going to be smaller than 90 degrees. Okay, so in other words, we're taking stuff and we are writing it in terms of the first quadrant and not in terms of the other 3 quadrants. All right, so now, first of all, before we carry on, let's just talk about the different reduction formulae for the different quadrants. So now, imagine my terminal arm is anchored at the origin, as it is here. Let me just, probably need to draw a new one. Okay, my terminal arm is anchored at the origin. Now, if it goes 180 degrees in this direction, I write that as plus 180. So we'll just write it as 180. Now, if I want to end up in the second quadrant, I would need to go forward to 180, and then I would need to go backwards, all right? And the number of degrees that I go backwards, it would have to be a value smaller than 90 to keep me in the second quadrant. And that's why we use the reduction formula 180 minus theta, where theta is an acute angle, as our reduction formula for quadrant number 2. Similarly, if my terminal arm is anchored at the origin and it now swings 180 degrees in this direction, and then goes another acute number of degrees forwards and comes to rest in quadrant number 3, I would say that I've gone 180 degrees plus theta. So 180 degrees plus theta is the reduction formula for quadrant number 3. And for quadrant number 4, what we do is we say that the terminal arm swings 360 degrees. So it does a complete circle, and then it turns around and it goes back in the other direction. So this is 360 minus theta. Right, so just to summarize that on a diagram that is hopefully a little less confusing than what I've written all over now, let's just do this over here. Okay, in quadrant number 1, all angles are acute. In quadrant number 2, we go 180 degrees in an anti-clockwise direction, and then we turn around and we go minus 30 degrees in the other direction so that we stop in quadrant number 2. To get into quadrant number 3, we go plus 180 degrees in an anti-clockwise direction, and then we continue 30 degrees in the clockwise direction so that we end in quadrant number 3. And for quadrant number 4, we go 360 degrees in an anti-clockwise direction, and then we go 30 degrees in the other direction, and that's how we end up in quadrant number 4. So when you see 180 minus theta, they are specifically referring to quadrant 2. When you see 180 plus theta, we are referring to quadrant 3. And when we see 360 minus theta, that is our reduction formula for quadrant number 4. Is everybody happy with that? Is this something that you have done at school or in some detail with Peter? Or am I telling you this for the first time? Can you pop something into the chat? Is it making sense? Are you happy? Any questions? Okay, so Lee, you've done this before, so I'm just revising what you already know. Elspeth, first time. Okay. All right, cool. Thank you for the feedback. Thanks, DNL. Okay, Taban, you've got your hand up. You're welcome to unmute yourself, Taban. Oh, sorry, mistake. Okay, all right, cool. Not a problem. Okay, so what I'm telling you now, you have heard before, and hopefully this all makes sense to you, which is great. That means that we can now go, what I want to do before we jump into the sorts of questions that we're going to answer, I just want to talk a little bit about how the trig graphs and the cast diagram match up with one another. Okay, so it's very important for us to also understand that when we are talking about trig ratios, let's just scoot over to the side here. I've already put these graphs here, but maybe I can just come past. It's very important to understand that when we are talking, oh, that's a terrible y-axis. When we are talking about trig functions, we're talking about a series of inputs and corresponding outputs. So our inputs on our x-axis, these are our angles, grade 11s. So 90 degrees or 180 degrees or 360 degrees. Okay, fine. The next one would actually be 270, etc., etc. So our angles go on the x-axis and our ratios go on the y-axis. So if we were drawing something like this particular graph over here, which is the graph of y equals sine x, right? What we find is that, for example, when 90 degrees goes in, the corresponding ratio is 1. Or if we've learned our special angles off by heart, over here, this would be halfway, so that would be 45 degrees. So the sine of 45 degrees is going to leave us with a value, it's actually √2/2. Or if we have the sine of 30 degrees, that's going to be a half. Okay, so these values here on the y-axis are our outputs. Okay, these are our ratios, right? Over here, what goes in, these are our angles. These are our inputs. Okay, and that's how we have a graph from a trigonometric function. Okay, so here's the input. And over here on the left-hand side, this is your output. Now, what's super important to remember here is that this is just another way of looking at the cast diagram. Up to here, grade 11s, this is quadrant number 1. Can you see all your ratios are positive because this line is above the x-axis where y is positive. That's why sine theta is positive in quadrant number 1. All right. Now have a look in quadrant number 2. This is quadrant number 2 over here, between 90 and 180. Can you see again, our curve is above the x-axis. So all our outputs that are generated by this function are above the x-axis. So they're generated in a space where y is positive. Then have a look what happens over here at 180 degrees. Now we go into quadrant number 3. So here we are in quadrant 3. And that's why sine theta is negative. Can you see our curve is below the x-axis? And the same thing with quadrant number 4. We can see that our curve is below the x-axis. And if we were to read off any corresponding y value at this point, it would be a negative number. Okay, so I think it's very important to see the cast diagram together with a trig graph to understand what we're talking about when we say ratios are positive or negative in specific quadrants. So that's what we are referring to. And it works in the same way with the cos graph. Now here, the sine graph is still the one that's in red. That's the one that we've just looked at, y equals sine x. And the purple one is the graph of y equals cos x. And if you have a look, the graph of sine x and cos x are actually very, very similar. They're actually identical to one another. They're just, one is shifted to the left of the other one. But I mean, if you can imagine, if I could grab hold of the purple graph and I could shift it 90 degrees to the right-hand side, it would actually be the graph of sine x as well. And that's also one of the reasons why, I don't know if you've done co-functions at school. So in other words, if you've got like the sine of 90 minus theta, why that gives us cos theta, for example. But that's not something that we're going to talk about today, but just later on, it all ties nicely together if you look at the graphs. Okay, so now here again, here's quadrant number 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. Now we're looking specifically at the purple line. Can you see that the purple line is above the x-axis in quadrant 1? It's below the x-axis in quadrants 2 and 3, and then it's above the x-axis in quadrant 4. So that's why in quadrant 4, on the cos diagram, we've got C in quadrant number 4. Okay, because the cos function is positive in quadrant 1 and again in quadrant number 4. And then our tan function, which I've got for you here in black, here is quadrant 1. Here is quadrant 2, here's quadrant 3, here's quadrant 4. So again, can you see that in quadrant number 1, so that's up to this point over here, can you see grade 11s, the tan function, which is in black, the sine function and the cos function are all above the x-axis, they're all positive, right? Then if we have a look at quadrant number 2, the tan function is below the x-axis. In quadrant number 3, the tan function is above the x-axis. In quadrant 4, the tan function is below. Okay, so our cast diagram makes sense in terms of what we've been taught, but it also makes sense in terms of our graphs as well. So I think that's really, really important to see, and I hope that that puts things together for you guys nicely. Okay, so now what we have to be able to do is simplify expressions that are given to us. So for example, they give us something like this: simplify as far as possible, and they give us the cos of 180 plus theta over the cos of 180 minus theta. So when they're asking us to simplify, they want us to apply the reduction formula that's given, and where possible, try and simplify our answer. So either we could write it in terms of a value, if that's possible, or we could write it in terms of a trigonometric function in terms of theta. So it works like this, right? So in the numerator of this particular question, we have cos 180 plus theta. So this is what we say. We say cos 180 plus theta. 180 plus theta is quadrant 3, where cos theta is negative. So this reduces to negative cos theta. Okay, so now I have written it in terms of an acute angle. Okay, but in quadrant 3, cos theta is negative. Cos 180 minus theta refers to quadrant 2. So in quadrant 2, cos theta is also negative. So this also reduces to negative cos theta. And then what we would do is we would say that anything divided by itself is 1. Okay, so negative cos theta divided by negative cos theta would leave us with 1 as our answer. And that's how we would simplify it as far as possible. Okay, so now I'm doing lots of talking here. How are you guys feeling? Is this making sense still? Did it help seeing the graphs? How are you feeling? Cool, Suzanne, thank you. Makes sense, sure. Okay. Okay, nice. All right, so please, if it doesn't make sense, please don't be afraid to speak up and ask questions. That's why we're here. We're here to help you. Cool. To help you make sense of these sorts of situations. Okay, and then these sorts of questions kind of get just a little bit more complicated, right? So now we see something like this. Okay, so we've got tan 180 plus theta. So now instead of me telling you what the answer is, I want someone to tell me what it is. So either I can pick on someone, or I suppose they could offer. Let's just have a look here. Anele, how would you reduce tan 180 plus theta? What would it reduce to?
I think it would reduce to minus 10 theta.
Okay, perfect, Anele. But why is it negative?
Because 10 is only positive on the first quadrant and the third quadrant.
Absolutely, but isn't 180 plus quadrant 3?
No, it's quadrant 2.
Unfortunately, Anele, quadrant 2 is 180 minus theta. Okay, 180 plus theta is quadrant number 3. Okay, so this, you were right in how you said that it would reduce, but unfortunately your sign was wrong. So this will reduce to positive tan theta. Okay, because tan theta is positive in the third quadrant. Okay, Neo, I see you've got a hand up. Do you want to ask a question?
Hello, hello, ma'am.
Hello.
I was going to answer this letter B.
Okay, well then, perfect. You take it away from here and you tell me what I should be writing.
Tan 180 plus theta is on the third quadrant. So it means it's going to be positive tan theta and sine 360 minus theta is on the fourth quadrant.
That's right.
It's gonna be multiplied by negative sine theta.
Lovely, Neo. Well done. Keep going.
We divide by, okay, tan 360 minus tan
I think Nompa's. Keep going, Neo.
Tan 360 minus theta is on the fourth quadrant and simply means it's going to be negative tan theta.
Beautiful. That's perfect, Neo. Well done. Okay, so whoever's teaching you at school is doing a great job and you're doing a great job of learning. That's lovely. Well done. What would we do from here, Neo?
Yeah.
Well done. It's lovely. What are you going to do now, Neo? Pohlale? Go for it. Do you want to answer?
Ma'am, I think we are going to cancel the tan.
Absolutely, absolutely. Okay, so in maths, anything divided by itself is 1. So quite right, Buhlale, I can say tan theta divided by tan theta leaves me with 1. What am I going to do about this negative and this negative though? What am I going to get? A negative divided by a negative is going to leave me with a positive. Absolutely. Absolutely. So this is going to leave me with a final answer of positive sine theta. Okay, so what you're doing is you're basically writing a term. And remember from grade 8, grade 9, grade 10, when we write a term in maths, we write it with a sign, and then sometimes we have a coefficient, and then we've got our variable, which in this case is our sine theta. Okay, that was really great. Well done. Okay, lovely. You're getting the idea. Okay, so we've always got to go back to our cast diagram and ask ourselves, in which quadrant are we working? And what is the sign of that ratio in that particular quadrant? We're going to practice this a little bit more now, but I just want to do one sort of slightly more difficult example with you, right? And this is 1 minus tan squared 360 minus theta. Now, this is a place where a lot of grade 11s end up losing marks, right? So it's very important that when you use a reduction formula, that you write what you get as a result of reducing, okay? So where we see sine 360 minus theta, we have to write minus sine theta. Or if we see tan 360 minus theta, we have to write minus tan theta. So when we use a reduction formula, we have to write what we get. Okay, that's one of the rules in trig. So what happens here with the square is this. When we are talking about a ratio being squared, it means that we are multiplying that ratio by itself. Remember, a square in maths is an instruction to multiply something by itself. So this is what's happening in this particular case. We are saying 1 minus, right? And then we have to work out what the tan of 360 minus theta is. Okay, so tan 360 minus theta means we're working in quadrant 4 where tan theta is negative. So this reduces to negative tan theta, and we have to write that, grade 11s, and this is going to be squared. All right, this is what it means. So now we know that when we square a negative, we end up with a positive, but when we subtract a positive, we're going to end up subtracting. So we're going to subtract 1 minus tan squared theta, like so. Does that make sense to everybody? Yes. Okay, so very, very important. Okay, if we are working with a square, so if they give us something like this, I'll make up another one. Let's say they give us sine squared 180 plus theta. You are not just allowed to go straight to the positive. Okay, you've got to show, yeah, you're quite right. Kiribone, I hope I said that correctly. It doesn't change sign, okay, but because you're squaring it, so it's always going to be positive, but you have to write the fact that it's negative. So if you've been given sine squared 180 plus theta, you have to first write that this reduces to negative sine theta, and then it's going to be squared, and then you're going to get sine squared theta, like so. Okay, you absolutely have to do that. All right, we're not allowed to do otherwise. Okay, otherwise you're going to end up throwing marks away. You cannot just go from here to here. Okay, they will penalize you. All right, so now I've done lots and lots and lots of talking. It's time for me to be quiet. I would like you guys to try and reduce as many of these as you possibly can to a single trig function of theta in 4 minutes. All right, so I'm just going to make that a little bit bigger. There's 8 of them. Let's see how many you can do in 4 minutes. Go for it. Okay, so there's a couple of minutes left. If you're done, you can pop a thumbs up or a smiley face into the chat. If you finished quicker than I said. Let's have a look. Okay, cool. Lungi's got a nice smile. That's lovely, Lungi. Thank you. Oratila's got thumbs up. So does Nomhle. Kedibone. Lovely. Good job. Okay. Papalo, Cody. Cool beans. All right. So this is something that should be fairly quick. That's fine, Bonga. The last 2 are in there specifically because they are supposed to be a little bit more difficult. That's why I included them. Okay, so let's get started and let's go through the answers. All right, so in the first one, this is your thinking. You see sine 180 plus theta. 180 plus theta is quadrant number 3. So this reduces to negative sine theta. In B, sine 180 minus theta, 180 minus theta is quadrant number 2. So this reduces to positive sine theta. In question C, 180 minus theta is quadrant 2. So this is negative cos theta. In D, cos 360 minus theta, quadrant 4, where cos theta is positive. So this reduces to positive cos theta. In question E, tan 360 minus theta, quadrant 4. So this reduces to negative tan theta. Your ratio is negative. Tan 180 plus theta is quadrant number 3. So this reduces to positive tan theta. And now for the last 2. Okay, so here, this is what we were supposed to do. Cos 180 plus theta. This reduces to negative cos theta because it is quadrant number 3, and I have to square it, so it reduces to positive cos squared theta. And then with H, tan 180 minus theta is quadrant 2, so this reduces to negative tan theta, and then I have to square it, in other words, multiply it by itself, so this reduces to tan squared theta, like so. Okay, how did that go? Did you get 8 out of 8? Neo, do you have a question? That went well?
Guys,
Okay,
can you pop in the chat how much you got out of 8? Just so we can get a sense of where you guys are.
Yeah, thanks, Coco. 7 out of 8, 8 out of 8. Cool beans. Nice, good job. Okay. So now I see there's a couple of you that have got 6. Is it because you got the last 2 wrong? Anyone got any questions? Please don't be afraid to ask. We're not judging you. We're here to help. And I do not mind. Younger, go for it, Younger. What's your question?
Ma'am, for the last 2 answers, the first part I got it correct, but then where you get the answer of cos squared theta and tan squared theta, why is it not negative anymore?
Okay, so Younger, that goes back to our grade 8 maths. Okay, to the idea that if we take a negative value, whether it is a negative sine theta or whether it is a negative number, and we multiply it by itself, we're always going to get a positive. So in other words, if I take negative 3 and I square it, it means negative 3 times negative 3. I'm taking whatever's inside the bracket, the base, and I'm multiplying it by itself. And that's why I end up with a positive answer, in this case, positive 9. And it means exactly the same thing. So when you've got minus sine theta squared, you are saying negative sine theta times negative sine theta. That's why you end up with a positive. Okay, so that's why it ends up being sine squared theta, like such. Does that make sense? Okay, that's where it comes from, and that's what it means. Okay, but you in grade 11, you have to show that you understand that when you work with a cos function and 180 plus, that you're going to end up with negative sine theta. So that first step in question G and question H is an essential step for you to show in grade 11. Okay, so now let's go and do questions that are just a little bit more difficult. And this sort of thing is very popular in grade 11. Often you'll see one of the questions that comes up will be like a 5 or 6 mark question where they get you to apply reduction formulae. And normally those 5 or 6 marks are allocated on you reducing correctly and writing either minus sine theta or positive cos theta or whatever the case is, and then simplifying your answer from there using maybe an identity if you need to, or anything divided by itself is 1, etc., etc. I think what I should do is, actually, mind you, we've spoken about this one over here. So these are really the same. What I suggest is you do 2, okay? Either do A and B, or if you want to try something a little bit more difficult, try C and D. Okay, so we're just applying reduction formulae and then simplifying where it's possible to do so. All right, so go for it. Either A and B, or if you want something more difficult, try C and D. And Coco and I are going to give you about 4 minutes. But again, when you're finished, if you can just pop a message into the chat or a smiley face or a thumbs up, then we'll know that you're done. Okay, go for it.
And I think I'm going to try these ones myself.
Okay.
And that's still
cool, Coco. Okay, Elspeth, you've got a hand in the air. Go for it if you want to ask a question. Cool, Nomhle. What's your question, Elspeth?
Can the answer end up in a fraction? Is that possible?
Absolutely. Absolutely, Elspeth.
Okay, thank you, ma'am.
100%, no problem. Sure, Kamvaletu, I will explain C with pleasure. We're going to go through all of them. I'm just waiting for a couple more people to put thumbs ups, and then we'll talk about all of them before we move on. Cool, nice. Okay. Let's just move that up a little bit. All right, so this is what we should have done. Okay, so there's a whole bunch of you with thumbs ups, which is awesome to see. Okay, so in question A, sine 180 plus theta reduces to negative sine theta times cos 180 minus theta reduces to negative cos theta. Okay, negative sine theta because 180 plus is quadrant 3, and negative cos theta, because 180 minus theta is quadrant number 2. Cos 180 plus theta reduces to negative cos theta, because that is quadrant 3, times sine 180 minus theta, that reduces to positive sine theta, because that is quadrant number 2. And again, in maths, anything divided by itself is 1. So sine theta divided by sine theta is 1. And similarly, cos theta divided by cos theta is also 1. What we need to be super careful of here, grade 11s, are the negatives, because we've got a negative times a negative divided by a negative. Notile, what's your question?
Hello, ma'am. My question is tan theta the same as sine theta over cos theta?
Yes, yes, it is. Okay, so that is one of the identities that you learn in grade 11. Tan theta is sine theta over cos theta, absolutely. And once you do the identities, whenever you see tan theta, you'll be writing it as sine theta over cos theta. I don't think we need to do that in any of these questions just yet, but you will be doing that. But yes, that's very important for you going forward. Quite right. Okay, so here, no problem. So a negative times a negative is a positive, and a positive divided by a negative is a negative. So here, to get full marks, we would have to say that the answer was negative 1. All right, now question B. We've got tan squared theta, that's the first term, minus tan squared 180 plus theta, that is quadrant number 3. So tan theta is going to reduce to a positive. All right, so here what's going to happen is it's going to reduce to tan theta like so, but this needs to be squared. So now we end up with tan squared theta minus positive tan squared theta, and anything subtract itself in maths, we should have ended up with 0 as our answer. All right, moving on, let's have a look at C. I know someone asked me to explain C. Okay, so tan 360 minus...
Before we continue,
Yes.
Lise, sorry to interrupt. I think Watobe has a question. Watobe, do you have a question? Hello, Watobe? Okay, I don't think so. All right. Sorry, just put.
All right, cool. No problem. You know, I don't mind being interrupted at all. Okay, so tan 360 minus theta is quadrant 4. So this reduces to negative tan theta. Cos 180 plus theta, quadrant number 3. So this reduces to negative cos theta divided by cos 360 minus theta, quadrant 4. So this reduces to positive cos theta. Oh, and that's not a times, that is a minus. So there's one term at the top, but there are 2 terms down at the bottom. So this is minus, and then cos 180 plus theta, that's quadrant number 3. So this reduces to negative cos theta like so. All right, now what I'm going to do is just move that down. We've got a bit more space to write. Let's finish this off. Oopsie, we've got this sitting in the middle of the road now. Okay, so this gives us negative tan theta times negative cos theta. So that would be a negative times a negative, which is a positive. So now we've got tan theta times cos theta over cos theta plus cos theta. And in the same way that we would say x plus x is 2x, so if we've got cos theta plus cos theta, we've got 2 cos theta. All right, so that means over here, Ntokozo, you got a question? You're welcome to ask.
Oh, ma'am.
Yes?
Ma'am, where did the negative after 10 theta times cos theta, where did the negative go?
Okay, so what I did there, intercausal, is I simplified my signs and I said that a negative times a negative is a positive. Right, I just didn't write the positive sign. Does that make sense to you? Negative
thank
times
you,
a
ma'am.
negative is a positive. No problem. All right, and then at the bottom, when I subtract a negative, I'm adding. So that gives me 2 cos theta at the bottom. Now, because I'm multiplying at the top and I'm dividing, I'm allowed to cancel. Right? I'm allowed to say that cos theta goes into itself once, and it goes into itself once over here as well, right? So my final answer, strangely enough over here, grade 11s, my final answer is going to be tan theta divided by 2. Who got that right? Who got that right? Did anybody who tried that? Pabalo, do you want to ask a question? Or you're just saying you got it right? You're putting your hand up.
Yeah, Lee, unfortunately, I fell for the trick too. I didn't see the minus and the minus, and I multiplied instead. So, so you guys, sometimes even the teachers get it wrong. So
yes,
yeah.
absolutely. So Pabalo, you say you got it right. That's great. Well done. Very nice. Let's just see who else has got a hand in there. Nzole, did you get it right as well?
Ma'am, I just want to ask something.
Yes.
Instead of like tan theta over 2, I said tan theta over cos.
Okay, now that wouldn't be correct. Okay, because you've got cos theta at the top and you've got 2 cos theta at the bottom. So cos theta divided by cos theta would be 1. So it's not, because you see the thing is, if it's cos squared theta at the bottom, then you could have a cos left over, but because it was 2 cos theta, it's not going to work that way. Let me just explain that again. All right, so Nzola, if you had tan theta times cos theta, and then over here you had cos squared theta, then you could end up with tan theta over cos theta, because here cos theta goes into itself once and it goes into cos squared theta number of times. And then you could end up with tan theta over cos theta. But that's not what this question was. All right, so 2 cos theta, essentially what you've got is you've got tan theta multiplied by cos theta over 2 times cos theta. That's what this means. All right, so when you divide the cos theta at the top with the cos theta at the bottom, you're going to be left with tan theta over 2. That's where it comes from. Okay, so it can be very, very confusing. We've got to be super, super careful about what it is that we're doing. All right, let's go back and go and have a look at the last question, which was question number D, and let's see how we did. Pleasure, Nzole. Let's see how we did in that one. Okay, so question D. Let's pick a different color. What color have we not used yet? Let's go for purple. Okay, so question D, sine squared 360 minus theta. Well, we know 360 minus theta is quadrant 4. So this reduces to minus sine theta, and that needs to be squared. That's our numerator. Over now at the bottom, we've got sine theta, and then that's being multiplied by sine 180 plus theta. That's quadrant number 3. So this is negative sine theta. So now at the top, we've got negative sine theta times negative sine theta, which gives us positive sine squared theta. And at the bottom, we've got positive sine theta times negative sine theta. So that gives us negative sine squared theta. And again, grade 11s and maths, anything divided by itself is 1. And 1 divided by negative 1 means our answer would be negative 1 as well. Okay, how did that go? How do you feel? Cool, Neo. Well done, Coco. Nice. Cool, Bradley. I'm glad. Well done, Oratile. I'm glad it makes sense. Nice. Yes, so Elspeth, is that why you were asking, can your answer be a fraction? Was it because of C? No problem, Cody. Cool. Hey, nice. Someone got 4 out of 4. I'm sorry, my pronunciation is Esonasihle. I don't know if I pronounced that correctly. I apologize if I didn't, but that's great. Well done. Cool, Quinda. You guys are doing so well. That's lovely. Nice. But you're paying that 75%. I'm happy with that if you are. That's great. Well done. Good job. Okay, nice. All right, so unfortunately, the time always just goes by way too fast, doesn't it? We've only got 3 minutes left, but I just quickly wanted to show you. Oh, it's a pleasure, Neo. It really is an absolute pleasure. I just wanted to show you what happens, not just in terms of 180 plus theta, 180 minus theta, but that we can actually apply this to numerical examples as well. All right, so let's just have a quick look at that just before, I almost said before the bell rings, but we're not at school, are we? Before it ends up being 7 and our time is up. Okay, so now sine 290 minus theta. Okay, now you've got to have your wits about you here, guys. 290, which quadrant would we be in? We would be in quadrant number 4, okay, because we would have gone 270 degrees, that's the end of quadrant 3. So 290 would be in quadrant number 4. So that means that we have to use 360 minus theta. So this becomes the sine of 360 minus whatever it is to give us 290. Okay, so in our bracket still has to have the same value as what we were given, which is 290. So that means that we're going to have to subtract 70 degrees. Right, and now we would say sine 360 minus quadrant 4, sine theta is negative. So this reduces to negative sine 70. Do you see how we can apply it to numbers as well? That's it, quite right, Kiribone. All right, then part B. All right, so the tan of 197. Again, ask yourselves, what quadrant are we in? Okay, we are in quadrant number 1, 2, 3, 4. We are in quadrant 3. Quite right, we're in quadrant 3. So we've got to use 180 plus. Okay, so this will be tan 180 plus 17. Quite right. Okay, yes, quadrant 3. Tan theta is positive in quadrant 3, so this reduces to positive tan 17. Okay, so we're not just working in terms of theta, we are also going to be working in terms of numbers. All right, and let's just do the last one quickly. I'm sorry we didn't get quite as far as that this lesson. Cos 120, what quadrant are we in, grade 11s? We are in quadrant 2. Yeah, perfect. Quadrant 2. Okay, so that's 180 minus. So this is cos 180 minus 60. Okay, this is going to end up being a special angle. So cos 180 minus 60 reduces to negative cos 60. Right, have you guys done special angles? You done special angles, yes or no? Yes, no. Some of you have. Okay, so when it comes to, cool guys, so when it comes to special angles, if those of you who haven't done it, I'm sure your teachers will do it with you shortly at school. But it basically means that we can rewrite minus cos 60 as a value, right? In this case, it's going to be negative 1 over 2. All right. And the reasons for that, yeah, special angles, yeah, you would have done it last year and then you'll do it again this year. And they're super, super important for grade 12 as well. Okay, but unfortunately, that's it. Our time is up. It goes by too fast. Well done, grade 11s. That was a great lesson. I hope you really enjoyed it. And yeah, hopefully Peter's better and you'll see him again next time. It was lovely teaching you. Are there any questions anybody wants to ask? It's a pleasure.
I think we really enjoyed that lesson. That was really fun. Thank you very much.
Cool. It's a pleasure. Any questions? Pleasure.